Subtracting integers. So in this lesson, you learn to subtract integers. If you recall in 2-4, you learned how to add integers using counters. We will use the same method at the beginning to be able to subtract integers. If we want to find -6 minus -3 using counters, we need to start with 6 negative counters and remove 3 negative counters. That's easy enough. You have 6 negative counters. We want to remove 3 negative counters. We end up with -3 counters. So 6 minus -3 will be equal to -3. So the difference is -3. And activity number 2, or example number 2, is where, okay, it all changes. We want to model 4 minus -2. Okay, again we start with 4 positive counters. Okay, let's do that again. Okay, we want to model 4 minus -2. We want to start with 4 positive counters. The problem is we don't have any negative counters. So we start with 4 positive counters, but we don't have any negative counters. So you can't remove 2 negative counters, can you? Because there are no negative counters. The solution for this is that we need to add 2 zero pairs to the mat. Okay, so we get our 2 zero pairs and add it to that mat. Okay, remember that adding 0 pairs does not change the value of the set. Okay, it's just like adding 0 to a number does not change the number. Okay, so when we do this, okay, we have now adding the 2 zero pairs. We now have a total of 6 positive counters and 2 negative counters. Now we can remove 2 negative counters. Okay, so removing 2 negative counters, we end up with 6 positive counters. So 4 minus -2 is 6. Okay, so the difference of 4 minus -2 gives you 6. Right? Take a look at number 1, 2 minus -3, and let's use counters to solve these problems. Number 1, 2 minus 3 means that you have 2 positive counters. Okay, and then you are subtracting 3 negative counters. If you notice, there are no negative counters in there. So what you need to do, or what we need to do, is add 3 zero pairs. Remember, when you add a 0 pair, you don't change the number. Okay, so if we add 3 zero pairs, now we can get rid of 3 negative integers, or 3 negative counters. Okay, so these are our 3 negative counters we can get rid of. If you notice now, 2 minus -3 will be positive 5. So this will be positive 5 right there. Okay? Take a look at another example, or another number. Let's take a look at the number 2. 2 minus 3. Okay? 2 means 2 positive counters, so we put 2 positive counters, and we need to subtract 3 positive counters as well, but we only have 2 positive counters, so what we need to do is add 1 zero pair to make it 3 positive counters. Okay, and if we take away the 3 positive counters, okay, so take these 3 away, you end up with -1. Okay, so 2 minus 3 is equal to -1 using counters. Okay. Example number 3, exercise. -2 minus -3. Again, we get our 2 negative counters. Okay, and we are going to subtract -3 counters, but there are only 2 negative counters, so we add 1 zero pair so that we can subtract 3 negative counters take away our negative 3, we end up with positive 1, a positive 1 counter. So 2 minus negative 3 is positive 1. Okay. Next example is 4. So negative 2 minus 3. Again, we get negative 2 counters. And we want to subtract positive or 3 yellow counters or positive counters. But we don't have any positive counters, so we add 3 0 pairs. Okay. So if we add 3 0 pairs, 0 0 pairs, and we take away the 3 positive counters right here, these 3, we take it away, we end up with 5 negative counters. So negative 2 minus 3 is negative 5. Okay, let's take a look at number 6. Number 6 is negative 6 minus 9. Again, we put negative 6 counters. 3, 4, 5, 6 counters. And we want to subtract 9 positive counters. But if you notice, we don't have any positive counters, so we get 9 0 pairs. Again, reminding ourselves that whenever we add a 0 pair, we don't really change the number. Okay? If you remember our properties, this is also the identity property of addition. When you add 0, the number remains identical. So, how many is that now? 1, 2, 3, 4, 5, 6 0 pairs. You need to add 3 more 0 pairs. Okay. And there you go. 1, 2, 3, 4, 5, 6, 7, 8, 9 0 pairs. Okay. So negative 6 minus 9. We take away 9 positive counters, and these are the 9 positive counters we are going to get rid of. That is 5. Get rid of that. And that is 4. Get rid of that. That's our 9. Okay. And if you notice, there are 15 negative counters left. So negative 6 minus 9 is negative 15. Okay. Let's try 13 minus 4. Okay. Oopsie. I took out the square mat. Okay, so 13 minus 4. No. Do that again. Let's do that side first. I'll just take out everything and I'm going to make a new mat. There you go. Okay, 13 minus 4. Again, 13 positive counters. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 positive counters, and you want to subtract 4 positive counters, so this is pretty simple. Okay, you simply take out the 4 positive counters and you have 11. So that's easy enough. Okay. Negative 8 minus negative 12. Let's do that. Number 7. Okay. Negative 8 minus negative 12. Okay, so you have negative 8 counters. 5, 6, 7, 8. You want to subtract negative 12, so you want to subtract 12 red counters, but there are only 8 of them. So what do? you add 4 more by adding 4 0 pairs. So if you add 4 0 pairs, okay, 2, 3, these are your 4 0 pairs right there, okay, and now you can subtract negative 12. If you notice, once you subtract negative 12, which are all of these, take those out, take these two out, and become negative 12, you end up with 4 positive counters. So negative 8 minus 12 is 4, and the last one, okay, last one, and let's delete this one, okay, last one, negative 4 minus negative 4, okay, you have negative 4 counters to start with, 2, 3, 4, okay, and you want to subtract negative 4, so that's easy enough. You have 4 negative counters, subtract negative 4, okay, you end up with 0. So if you take all 4 out, end up with 0. So negative 4 minus negative 4 is 0. Alright, done with that. Let's move on. Let's do it another way. Adding and subtracting are inverse operations that undo each other. Okay. Similarly, when you add opposites like 4 plus negative 4, like what we did in the last last number, the sum is 0. So when you have positive 4, okay, minus negative 4, basically have 4 0 pairs, take them all out, it becomes 0. And if you do it on the number line, okay, you have positive 4, okay, and then from positive 4 or negative 4 first, and you add 4, so negative 4, you move 4 units to the left, and then you add 4, moving 4 units to the right, it'll go back to 0. Okay, so from there, okay, we know this. An integer and its opposite are called additive inverses of each other. So in words, the sum of an integer and its additive inverse is 0. So 5, the additive inverse of 5 is negative 5, which will give the sum would be 0. And if you want to take it one step further, in algebra, okay, when you have x and get the additive inverse of x, which is negative x, the sum would be 0 as well. Okay. And at the beginning of the lesson, you were asked to compare the result of subtracting an integer with the result of adding its additive inverse. Okay, so you were given this. You have negative 3 minus negative 2 equals negative 1. So when you add this using additive inverse, it becomes negative 3 plus 2 equals negative 1. Okay, you're basically getting the additive inverse of negative 2 and adding it to negative 3, which will give you negative 1. Take a look at another example. When you have, sorry, before that, no. Okay, so this one, that one. When you have 4 minus 6 equals negative 2, we know this by using counters. Okay, we can do the addition part of this. When you have 4 minus 6 equal negative 2, we can add the additive inverse of 6. So add the additive inverse of 6 is negative 6. So we simply add negative 6. 4 plus negative 6 equals negative 2. Okay. The next example, we have negative 1 minus negative 5 minus 1 equals negative 6. Again, using counters, we were able to establish this. Okay, so when we use the additive inverse, the additive inverse property, we simply get the additive inverse of 1 and add it to negative 5. So this becomes negative 5 plus negative 1 equals negative 6. Because the additive inverse of 1 is -1, and we change subtraction into addition. Okay, so our subtraction here becomes addition here. Okay, and that's how you use additive inverse to subtract integers. Okay, these examples suggest a method for subtracting integers. So when you subtract integers, add its additive inverse. Okay, in arithmetic, 3 minus 5 equals 3 plus -5. In algebra, a minus b becomes is equal to a plus -b. So when you're subtracting integers, okay, you don't want to use the counter method. You don't want to use the number line method. Okay, you can use the additive inverse property to subtract integers. 3 minus 5 is equal to 3 plus -5. Or in symbols, a minus b is equal to a plus -b. And let's see how this works. For example, number 1. Let's solve 7 minus 12. Okay? In 7 minus 12, we get the additive inverse of 12, which is -12, and add it to 7. So this becomes 7 plus -12. Okay? And then 7 plus -12 becomes -5. Okay, so to subtract 12, add 12. Add -12. Letter B, 6 minus -11, okay, equals R. Okay, and if you notice here too, you will get the additive inverse of -11, which is 11, and add it to 6. So this becomes 6 plus 11. Okay, to subtract -11, okay, and then from there simply add 6 plus 11, which will give us 17. Okay, letter C. Okay, problem is -3 minus -8. We want to get the additive inverse of -8, okay, and add it to -3. So this becomes -3 plus 8, okay, to subtract -8. And using counters, using the number line method, okay, we know that -3 plus 8 should be equal to 5. Okay, -9 minus 16, or on example 1D, we get the additive inverse of 16, which is -16, and add it to -9. Okay, to subtract, okay, 16, we add -16, and then the sum would be -25. Okay, let's take a look at the example number 2. You can use equations with integers to represent real-life situations. The highest point in Africa is Kilimanjaro in Tanzania. It has an altitude of 5,895 meters above sea level. The lowest point on the continent is Lake Assal in Djibouti. It is 155 meters below sea level. Find the difference between these altitudes. Let's analyze this problem. Okay, and in the Explore, with the sea level as a starting point, 5,895 meters above sea level can be expressed as positive 5,895, or simply 5,895. 155 meters below sea level can be expressed as -155 if we let if we let sea level be 0 in this case. So sea level is 0. Okay, that's sea level. Okay, anything above sea level would be positive, anything below sea level would be negative. So in this case, since it's above sea level, it's 5,895. 155 is below sea level, so we have -155. Okay, important in a word problem is that we represent or we define the variable. In this case, we let D represent the difference. Okay, that's what we are trying to find out. In solving this problem, we plan it first, translate the words into an equation using the variable. Okay, we use d. Okay, so the difference d, okay, is, which is translated as an equal sign, and then we look at the altitude of Kilimanjaro, which is 5,895, and then we subtract, because we're looking for the difference, the altitude of Lake Assal, which is negative 155. And using what we know about the additive inverse property in adding integers, we now have 5,895 minus 155. To subtract 155, we need to add the additive inverse of negative 155, which is 155. So we simply add 5,895 plus 155. Okay, we basically add the additive inverse of negative 155, which is 155. Sum would be 6,050. Okay, so the difference in altitudes is 6,050 meters. And to be able to check if our answer is correct or not, we simply create a diagram and let's see if our solution makes sense. So you have 6,050, which is what we got. Lake Assal is 155 below sea level. Kilimanjaro is 5,895. It makes sense. Okay? Let's take a look at example number 3. Example number 3, let's do some algebra. You can use the rules for subtracting integers to evaluate expressions and combine like terms. So let's evaluate b minus negative 5 if b equals negative 15. Remember, the word evaluate means to find the value of, and 2 steps to find the value of: substitute and simplify. Okay, first b minus negative 5. Okay, we replace the value for b, which is negative 13. So this becomes now negative 15 minus negative 5. Okay, the first step of evaluating is substituting, which is this step right here. And then when you subtract integer, you add its additive inverse. So we get the additive inverse of negative 5, which is 5, and add it to negative 13. Okay, subtract negative 5 by adding 5, additive inverse property, and we end up with negative 8. Okay. Example number 4, we want to simplify 5a minus 13a. Okay, 5a minus 13a. So we get the additive inverse. When we get the additive inverse, you basically get the additive inverse of 13a, which is negative 13, and add it to 5a. Okay. Using the distributive property, you simply have 5 plus negative 13 in brackets multiplied by a, and simplifying 5 minus 13, that's negative 8a, add 5, and negative 13. Okay, so that is example number 4, and we've come to the end of our lesson. On Google Forms, type a summary of what you've learned by responding to the objective of the lesson, and type a question you might want to ask in class about this lesson. Thank you.